Chemistry 2, Chapter 15, Acid Bases. This is Part 1, Video 1, and then there'll be a Video 2 for Part 1 in a few days. So 15.1 is all about just general properties of acids and bases and also how to name them. So some general properties of acids. If you can actually taste an acid, which not all acids you should eat or consume, acids have a sour taste to them. Acids are corrosive to skin, fabric, and metals. When they corrode, they do release H2 hydrogen gas. Acids will form electrolyte solutions that will conduct electricity. And acids will react with a base to form salt and water, which we will get into more detail about later. Some general properties of bases. If you can taste a base, which once again, you shouldn't necessarily consume everything, but they will taste bitter. Soap is an example of a base. So if you've ever got soap in your mouth, you know that bitter taste it has. Bases feel slippery. So if you get a base on your hands, it has a very slippery feeling to it. So once again, example would be soap. So bases are corrosive as well. However, they are only corrosive to skin and hair, not fabric and metals. These do form electrolyte solutions as well, which can conduct electricity. And if you react a base with an acid, you also form a salt and water. So part 2 is actually naming the acid and bases, part 2 of section 1. So how do you name acids? There's 2 different versions. The first version is a binary method, bi need to. The second is a ternary or oxyacid, where you have more than 2 elements. Almost all acids do begin with an H. Kind of makes them easy to identify if you have a group of elements, or I'm sorry, a group of compounds. So how to name binary acids? So binary acids are made of 2 elements, the first of which is always hydrogen. It doesn't matter how many hydrogens you have as long as it comes first, and there's only one other element. And basically, the rule for naming binary acids is to put the prefix hydro for the hydrogen present, and then you say the name of the second element present with the suffix IC. So hydro something acid. So for example, HCl, 2 elements, H and Cl. The trick they say is to remember my ride has hydraulics. Okay, so chlorine was chloride. So now you make it hydro for the H, the name of the element, and X, ick. Some people like to remember that, some people don't. It's up to you. So normally we would say hydrogen chloride, but now we're naming it an acid. So this would be hydrochloric acid. So here's some examples. Use that rule, hydro for the H, the element name, and add the IC. So pause the video, try these out, and we'll go over the answers. Okay, so hopefully you try those. Let's go over the answers. So the first one is HB. H for hydrogen, B is boron. So this becomes hydroboric. Boron becomes boric, and then acid. Okay, try the next one, HI. H for hydrogen, I for iodine, which will become iodide. The IDE changes to IC. So once again, hydro, iodic, hydroiodic acid. What about HF? H hydrogen, F fluorine, which becomes fluoride. Change that to IC, hydrofluoric She spelled it right, UO. And the last one, it does have H2S. It's still two elements starting with H. So hydro for H, and S was sulfur, which would become sulfide in general naming, which now becomes sulfuric. So now just sulfuric. So you actually use the whole sulfur there. Okay, so just some examples of naming binary acids. Hydro, the element name with IC on the end, and you'll get used to how to cut them. It's not hydroboronic or hydroiodinic, but it is hydrosulfuric. You'll get used to how you cut them the more and more you hear. Okay, what about naming ternary acids, which are also called oxyacids? These are going to be made of three elements: hydrogen, usually at the beginning, followed by one of our nonmetals to the right side of the periodic table towards step line, and then ends in oxygen, hence the oxyacids, potential names of ternary acids. So once again, you're going to most likely have hydrogen followed by a polyatomic ion or a radical that ends in oxygen. So the rules: first off, break it apart into its ions, and then use the chart below to name the negative ions. So if you have an ion ending in ATE, or should I say a radical, you change to IC. So for example, HNO, so we have hydrogen, and then we have NO, so that's what's saying break it apart into its ions. H is positive, NO3 is negative, and NO3 is a radical, and it is nitrate. So 8 becomes ick. And they tell you to remember, I ate something icky. Change 8 to ick. You don't do anything with hydro though. You just name it based on the polyatomic ion, the radical, and then change the ending and add the word acid. If you have your polyatomic ion radical ending in ITE, you change it to OUS. So for example, HNO2, you've got the positive hydrogen, the negative NO2, NO2 is nitrite. So ite becomes us. They tell you to remember Sprite is delicious. Change ITE to OUS. So this is not nitric acid, it's nitrous acid. So try these examples, pause the video, and then we'll go over them. Okay, so first example, we have H2CO3. So once again, we're going to break it apart into its ions. The H is a positive ion, the radical is negative. CO3 is carbonate. So we change ATE to IC, I ate something icky, and this becomes carbonic acid. You don't add that hydro before it for ternary. All right, what about the next one? HClO2. So once again, H is our positive ion, ClO2 is our negative ion. ClO2 is our radical chlorite. So we change ITE to OUS. My Sprite is delicious. And this becomes chlorous acid. Okay, so if you have an ATE for a ternary, you change the ending to IC and add the word acid. If you have a ITE ending, you change it to OUS and then also add acid. No hydro. That's only for binary. Okay, and lastly, how do we name bases? Well, bases are quite simple. You're most likely going to have a group 1 or group 2 metal plus an OH hydroxide on the end. So basically, you just say the name of the first element, the metal, followed by hydroxide. Super simple to name. So example, NaOH. Na is our metal, sodium, and then OH is hydroxide. So this base is sodium hydroxide. Easy as that. So pause the video, try these ones out. Remember, it doesn't really matter how many of something you have. You're not doing any prefixes or anything like that. You're saying the name of the metal and then saying hydroxide. So try these out, pause the video. We'll go over the answers. Okay, so first one, we have Ca, calcium, and then OH, hydroxide, no prefix there, it's a radical. AlOH3 would be aluminum hydroxide. And KOH would be potassium hydroxide. Spelling is important, guys. So you have your periodic table, you use it to your advantage. You should know how to spell these by now. Okay, so that is part 1, video 1, general properties of acid and bases and naming binary and ternary acids and just bases in general. And there'll be a part 2 video eventually.